All right, so we're going to start 3.2 linear functions today, and we are actually going to skip this number 1. It would have been used as a warm-up if we were in person or if we had a little bit more time, but it's cool to do if you wanted to go through that, but we're going to skip it for now. So the first thing we're going to talk about is function notation. So function notation basically is just a method for writing variables as a function of other variables. So typically you see this as f of x for function, but it could be something like g of x or h of x or whatever. Okay, you could see something like h of t. It doesn't have to be x. It is very often though. Basically, what these are replacing is something that is your output, which is typically your y value. So it's just another way of writing y, essentially. So let's think about these. So if we wanted to write y equals 3x plus 4 in function notation, we would write this, okay? So instead of y equals, it's going to be f of x equals. All right, and what f of x is it's representing the new name. Okay, it's your function. The variable inside the parentheses is called your input, which is typically your x. And the whole thing itself is the output. Now, what that output equals is your rule. Okay, you will have to know this word. It gets used a lot. Input, output, not used all that much, but this, what it equals is called the rule. It's the equation. So we're going to use all of that notation to help us out here. Okay, so it says, part B of this question, so this is still the same example, it says a function can be thought of as a machine that assigns one output to every input. Illustrate this idea by finding f of 2 using the function machine below. So essentially what we're doing is we're putting f of 2 in. So we're plugging 2 into the equation, right? Obviously 2 took the place of x, so instead of 3x plus 4, it's going to be 3 times 2 plus 4. Now the output, or the f of x, is actually whatever that equals. So 3 times 2 is 6, 6 plus 4 is 10. So then it says in part C, let's go ahead and graph that equation. Well, f of x equals 3x plus 4. And that is in slope-intercept form. So we're going to go up 4, and then we're going to move our slope of 3. So up 3 over 1, up 3 over 1, and do it again a couple times before drawing your line. Remember, draw your line all the way through the graph. Okay, so as you can see, it's very similar to things that you've already been doing. It's just written differently. So really nothing new except for the notation. So what we're going to do now is try to find function values. So I encourage you to pause the video and see what you can come up with for at least the first couple, and then I'll go over the answers. Notice how we did not divide by 2. F of 2 is way different than 2f. Okay, 2f, we would get rid of the 2, right, by dividing it. But we want to find what f of 2 is, and so we leave it just like that. Now we have g of 2. So again, we're going to plug it in to our x squared plus 3. So that is our new x value. And 2 squared is 4. 4 plus 3 is 7. So g of 2 is 7. Now you could just write 7 and circle it. I'm fine with that. But technically g of 2 is 7. And our last one like this is talking about h of x. So h of x is negative x plus 7. So whenever you have something like a negative x, that's really like negative 1 times x, right? So in this case, negative 1 times x would be times negative 1. Well, negative 1 times negative 1 is 1, plus 7 is 8. Okay, so then we get into 4, 5, 6. These ones might have stumped you a little bit. What we're doing on number 4 is we're taking what f of negative 5 is, and then we're going to add 7 to it. Okay, so I would just focus on f of negative 5. So if we plug that in, we'd get 2 times negative 5 minus 3, which is negative 10 minus 3, which is negative 13. Now, I need to throw in this whole plus 7 thing. So my final answer would end up being negative 6. And you could write out f of negative 5 plus 7 equals negative 6. Either is fine. So on number 5, I would do the same thing. Okay, we're going to find g of 8 first, and then we're going to multiply by that 2 that's on the outside. So g of 8 is 8 squared plus 3. I encourage you to definitely keep them in parentheses. It makes more sense when we get into negatives. So we have 64 plus 3, which is 67. Now, if I want to throw this 2 on, it needs to be 2 times that 67. And 2 times 67 is 134. Again, that's what 2 times g of 8 is. And then we have one like number 6. H of 5 minus h of negative 7. So what I would do is find h of 5 and then find h of negative 7, and then we're going to take those two values and subtract them. So h of 5, that would be negative 1 times 5 plus 7, which is negative 5 plus 7, which is 2. Then we have to find h of negative 7. So this one would be negative 1 times negative 7 plus 7, which gives me a positive 7 plus 7, which is 14. Now it says we're going to take h of 5 and subtract. So it's 2 minus 14, which gives me negative 12 as my final answer. Okay, so this is a big part of today. This is something that you're going to do here on out periodically. So it's definitely a very crucial part of this chapter. The next part of the lesson is focusing on finding linear equations based off of a table. Okay, so remember, big things that we need are slope and a y-intercept, right? We need slope and y-intercepts, right? So we have to find those. Remember, slope is change in y over change in x, and your y-intercept is when x is 0, right? So the first thing we want to do is focus on what's happening between each, okay? The same thing should be happening each time, which in this case it is. It's going up by 1. The bottom is also having the same thing happen, and it is increasing by 6.5. Okay, so this does mean my slope, which is change in y over change in x, is going to be 6.5 over 1, or 6.5. Now, yes, slope should technically always be a fraction. This is 6.5, so you can rewrite this as 13 halves. Okay, but you don't necessarily have to for these specific problems. All right, so we found our slope. Now we want to find our y-intercept. Remember, this is where x is 0. So if we can know what x will be when it's 0, we can use that for our equation. And if you think about it, using this pattern, if we just go back the same amount, right, we would have 0 for our x. And that means that that value would be our y-intercept. So all we have to do is go the reverse, so subtract 6.5. And that means my y-intercept is 0. So if we write this as an equation or as a function, f of x would be your slope times x, and then you can put plus 0, but you don't have to. Okay, or you could write 13 halves x. So let's do another example like that. Okay, on this one, if you notice, you are adding 2 each time, right? And then this one is subtracting 4 each time, and so on, right? So again, change in y over change in x. So we have negative 4 over 2, which reduces to negative 2. At this point, if you try to do what we did before and go 1 backwards, we would have to subtract 2, which would put us at negative 1. So because we don't have where x equals 0, we have to go a different route. Well, if you think about it, all of these are points. So we can use any one of them, and I'm going to use the first one, but you can use any. And we're going to put in point slope. So y minus the y1 equals our slope times x minus the x1. Now, technically, it doesn't tell us that we have to change it, but I do want this in function notation, so it should be f of x equals something. So we're going to go ahead and solve. So we distribute, and then we would add 5. So we get y equals negative 2x plus 7. Now, the problem is, again, we want function notation, which means we need to rewrite it as f of x equals negative 2x plus 7. So it says Tamika records the outside temperature at 6 o'clock a.m. and finds it is negative 3 degrees Fahrenheit. Okay, so 6 a.m., negative 3 degrees Fahrenheit. The temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. Oops. Assume the temperature continues to increase at the same rate. Okay, so we're outside at 6 a.m. and we find that it's negative 3. Then it's going to increase by 2 degrees every hour. So hopefully we're like, oh, every hour? That means that this is probably your slope, right? Because it's talking about that rate, right? The rate of change. All right, so we have a good starting point, right? At 6 a.m., this is what happens, right? So this is our initial point, which is your b or your y-intercept. Okay, so if we want to write it in function notation, f of x equals 2x minus 3. It says, what will the temperature be at 11 a.m.? What will the temperature be at 2 p.m.? Okay, now this is where we need to think about what we're plugging in, right? 6 a.m. kind of is like our 0. So if 6 a.m. is 0, then 7 would be 1, then 8 would be 2, then 9 would be 3, 10 would be 4, and 11 would be 5. So this is 5 hours, right? So we're really talking about plugging in 5 for x, not plugging in 11. Okay, there's a difference. So temperature at 11 would be 2 times 5 minus 3, which is 10 minus 3, which is 7 degrees Fahrenheit. Then we would go to the next one. Well, if 11 is 5 hours later, then 12 would be 6, 1 would be 7, and 2 would be 8, right? So we're plugging in 8 for x here. So 2 times 8 minus 3 is 16 minus 3, which is 13 degrees Fahrenheit. Does using a linear function realistically represent the temperature for the domain of 0 to 24 for x? Well, if you think about it, this is a 24-hour time span, right? And think about day and night, right? Isn't it normally colder at night than it is during the day? And even during the day, it's colder in the morning and then warmer in the afternoon, but then cold in the evening, right? Right? So no, because temperature changes at different rates all day.